Hey guys, hope everyone's doing okay. Today we're going to be going over parabolas. This is definitely not a new topic. You've just graphed parabolas or quadratics many times over the last couple of years, especially in Algebra 1 and Algebra 2. Alright, so today I'm going to be going over, kind of looking at from conics. There's a couple of new things that we're going to talk about. The focus, directrix, focal width. Vertex axis of symmetry is definitely not new. Okay, there are a lot of rules, so what I'm going to do is I'm going to go over kind of the basics and go over a couple problems with you guys, and then I want you to complete the 4 problems on the back of the page. Okay, so first thing I'm going to do is I'm going to go ahead and I'm going to draw our shape here, and then kind of just describe to you what's kind of going on with our shape right here. So our parabola. So first things first is our vertex. Okay, our vertex right here, which we would call h comma k. All right, that is our extreme, either the extreme lowest point or highest point, depending on how it opens, up or down, or our extreme left or right point. So we would say extreme min slash max if it opens up or down. Okay. Or extreme left slash right point. And so that would look like this. That would either be opening to the left, which we'll talk about shortly, or opening to the right. Okay. Our axis of symmetry, okay, our axis of symmetry goes through the vertex here. We've talked about this before, and kind of just splits the graph in half. Okay, so it is a line that goes through the vertex and focus, which we'll get to that word in a second here. Okay, and cuts the parabola in half. Okay. Our focus, which we'll talk about here in a second, our focus, this little X I'm drawing right here. Okay, that little X right there, that's our focus. Okay, and what we say to that is the focus is a fixed point on the AOS, which is axis of symmetry, inside the curve. Okay, and we'll talk about this a little bit more, but this distance from the, and this is why this is a solid line right here, we call that P. We call it P. So the distance from the vertex to the focus, okay, the distance from the vertex to the focus is what we call P. Okay. The directrix, so the directrix, which was always going to be y equals, okay, y equals when it's a horizontal directrix. There's times where it will also be vertical, and we'll talk about that shortly, okay? All right, a fixed line perpendicular to the axis of symmetry. Okay. All right. And then last but not least, our focal width. Okay. Oh, and sorry. The distance from the vertex to the directrix we call negative p. Negative p. Okay. So P just going the opposite direction. Okay. So if P was up 2 to get to the focus, it would be down 2 to get to the directrix. That type of thing. Okay. The focal width. All that is it's the width of the parabola through the focus. Okay. So, and we'll talk about that more as we are kind of going through these problems. Okay, so that's kind of the gist of it. If the parabola opens up or down, I'm going to draw off to the side here too. If it were to open left or right, so you can kind of get a gist of it. So pay attention here now. So if you look off to the next part right here, this now, because it's opening to the right, this is our directrix. Okay, we're going to draw our vertex here. Okay, that's H comma K there because that's our vertex, right? Okay. Now, how do we get to here's our axis of symmetry. Our axis of symmetry now is going horizontally through it. Okay, and so our axis of symmetry now is actually y equals, whereas our directrix now is going to be x equals because it's opening up or down. Okay. Our focus, our fixed point, is still inside the parabola. It's always going to be inside the parabola, and we call that distance right there, that's p. So then to get from the directrix to the vertex, we go opposite. We say negative p. Our focal width goes right through the focus. Our focal width goes right there through the focus. It's just the distance. It's just the width of the parabola through the focus. Okay. As you can see, okay, we've got a lot going on here. So we've got our vertical axis of symmetry. So when we have a vertical axis of symmetry, here's our formula right here. Okay, and this kind of just puts it all together for you guys. Right, I kind of listed it all on the chart here. Okay, our vertex, like we talked about, is H comma K. Okay, when our parabola opens up or down, okay, our axis of symmetry is equal to x equals h. Okay, now how do we know when it opens up? Well, if p is greater than 0, the parabola is going to open up. If p is less than 0, the parabola is going to open down. Also, what you need to notice, and you'll see 4p right here, x is squared. So when x is squared, okay, when x is squared, the parabola is going to either open up or down. Now, when y is squared, like in this second box here, okay, and p is greater than 0, the parabola is going to open to the right. When p is less than 0, the parabola is going to open to the left. Okay. Now, guys, what I would say is, I'm sorry that's going in and out the picture, I stopped it. Okay. What I would say is to start getting used to kind of, getting used to these formulas, because this is technically how we are going to go about graphing these parabolas. Okay. Give you a minute to break to get everything caught up, and then we'll continue on by doing the problems below.